So, a lot of people want to get into blacksmithing and they like solid fuel forges, they're like me. And so, the first thing they do is they build a forge and then they realize that blowers are hard to find. So they settle with like a leaf blower and an air gate or a hair dryer or something. But what if you're like me and you're a nerd about it and you don't want to use something that's powered? Well, the best thing to use is a hand crank grinder, a little bit like the one you've seen me using here. And they come in different forms. I've got another one over here that was made here in Australia, and I even have a really chunky one down there. Where is it? Yeah, there. That's an old Buffalo one from New York, and it's huge, and I'm restoring it. It's very, very old and needs a lot of work. But what if you can't find them? That's a real problem. They are a vintage tool, and because of that, you can't really find them easily, depending on where you live. Some places are all over the place, but here in Australia, they're few and far between. So this video is going to show you how to build one out of wood. Now, you wouldn't think that that would be very effective. However, Japanese blacksmiths have been using these things for a long, long time. The design hasn't really changed because it works. And they're called a Fuigo. I think I'm pronouncing that right. Probably not, but Sam Towns will probably tell me. He's a weeb, so he knows everything Japanese. Yeah, but we're going to be making one today with just basic tools and just some plywood and some pallet wood and a little bit of leather. We'll get into that a bit later. So it's not going to be a super in-depth tutorial. It's going to assume a certain amount of woodworking knowledge, but pretty basic stuff. So follow along and let's build a Fuigo. So in order to be pretty accessible, this whole thing, the wood that we're using is going to be plywood that you can buy in the sheets from pretty much any hardware store, and some old pallets. So first step is going to be to break down the pallets. I want this build to be, you can build Fuigos to be really nice, like works of carpentry art. That's not what we're doing today. We're making a functional one. If you are proficient in woodworking, go nuts. Really make it nice, make it your own. But if you are just a sort of a basic DIY woodworker, then just dive in, use these sort of scrappy materials, and I'll show you how to build one that works really, really well. So in carpentry, there are two types of measurements. There are things called critical dimensions and non-critical dimensions. Critical dimensions have to be pretty much bang on in order for the project to work. Non-critical dimensions don't. They can be within a wide range of what your intended measurement is, and the project will still work. Now, the cool thing is about a Fuigo, there are certain critical dimensions, but there is a little bit more wiggle room than you would get on a standard carpentry project that requires precision. So what we use is, before they had sort of standardized tape measures and things like this, they used things called measuring sticks, and measuring sticks were like an agreed upon measurement. They actually help you to maintain your critical dimensions really, really well. So for a Fuigo build, you need two critical dimensions, and one is the internal short dimension, which you make a block. It doesn't matter how long this block is, but this is going to be what you use as the reference point to measure everything. So this is your short dimension, how wide the Fuigo is and how tall the Fuigo is. And then you have a longer one, which is how deep the Fuigo is. Now, Fuigos can be quite big. It all depends on how much air you want to move, how efficient you want to make them. This is going to be a relatively small Fuigo, but still be quite functional. So we use this stick to make sure that all our measurements, and use it to cut all of our distances and things for the inside of the Fuigo on the long dimensions, and this will be the short, so both the height and the width. I said we're not going to get too deep into the carpentry of this, but one thing is really important on a Fuigo build, and that is squareness. So have a square, and all of your measuring sticks for critical dimension, you need them to be very square. So however you cut them, use a measuring square to ensure that they are actually square on the ends, because this will make or break your project, guaranteed. So like I said, we're doing this out of sort of pallet wood, scrap wood, and some plywood, which is nice and easy to buy from the shop. Now, you want to use at least 7mm plywood, preferably 9 or 12mm plywood. So what's that, 1/2 inch plywood would be great, because it makes it nice and stout. You need the sides to be straight and not have a bend in them. Now, if you are like me and you buy your plywood in giant sheets like this, which is 2.4 meters by 1.2 meters, you're going to have to break it down so that it's more manageable to cut. If you don't have table saws and things to do that, then you can use a hand-powered circular saw, which is what I'm going to be using. But you'll see, if you look down the length of it, there's quite a bow to that. And so we're going to kind of cheat getting it straight by using our sort of pallet wood and things, which is much more tough and straight, and use that as sort of guide rods. And then we'll check the inside surface and make sure that it all conforms to our measurement sticks. That might sound complicated, but it'll make sense very, very shortly. First thing I'm going to do, moving that around is going to be nightmarish, so I'm going to break it down to manageable pieces so that we can then get the rough dimensions sorted out for our Fuigo box. Okay, so now we've broken that down into a smaller piece. This little bit has about all the wood that we're going to need, probably some more, to be honest. I like to start with more than I need, just in case. So this is where we start our first critical dimension, which is going to be basically we're making a box that doesn't have a top and it doesn't have a bottom. We'll sort those out later. For now, it's just going to be 2 long sides and then 2 short sides. Now the short sides are the end pieces, and we're going to use them as our first critical dimension that we're measuring. So we're going to basically cut a strip along that edge there that is as wide as our critical dimension here. So I can actually use that, put that there, mark it, put it at the other end, mark it, use a straight edge to cut a straight piece, and then all of my end pieces can be cut out of that. So these are going to be our ends, there and there, and I have just used, like we've already cut widthways to our critical dimension, so I've done left space for our critical dimension again in this way, and then I've added a section here, and this section is going to be for our air gate, and this is where the air comes out of the bottom of the Fuigo. So how much you leave there is not a critical dimension, it's just that every time you do it, you got to make sure it's the same. I've chosen to do 6 centimeters, nice little narrow one, because I'm trying to make about as compact a Fuigo as you can really make and still have it functional. It may be narrow this way, but because of the width this way, the volume of air it will be able to move will still be quite high. Let's have a little bit of a talk about how Fuigos work. Now, Fuigo is essentially a long box. Like that. And inside that box is a smaller box down the bottom. That lines up with the bottom like this. There's a smaller box here, and a little shelf there, a little shelf there, and all this is hollow inside there. So in the middle of the large box at the top is going to be a square of wood, and we're going to cover that in felt. I'll get into that later, but square of wood here that is attached to a long rod that will come out a hole in the side of the box, and we'll put a handle on there. Now that rod lets us slide this piston essentially all the way down there and then all the way back. And above here is going to be a hole, and above here is going to be a hole. And we're going to build out of leather little one-way vents. So air will only be able to go in here. Let me get that again. In here and in here, not out. And I'll show you how to make them later. But basically that's the theory. Air can only go in these holes. And down on the bottom of the bottom box, there's going to be a hole here and a hole here. And air can only go in these as well. So when we push the piston this way, air's going to flow in this hole and then out this hole. So we'll have a exit point there, and exit point there, a little wall, and basically the same thing. We'll have valves that only allow the air to go this way. So We'll push that there. Air won't be able to flow back out this hole. It'll flow down there and out. And on this one here, when we slide the piston back this way, air will flow in here and be pushed out through there and that way. So we need to have a critical dimension on the sides of the piston and the sides of the box where the piston slides, because we need to have minimal gaps across here. And then we need to have this inner box, which is not critical in its dimension, but it allows the air to flow out. The other critical dimension is this length, because we are making a box and we need it to actually sit together nice and neat. So we want everything to be nice and tight tolerances around where this will go. Wherever the piston is going to slide needs to be fairly critical dimension, because any air gaps around the side are going to make there not be able to hold pressure, and air is just going to float back and forth, and we need it to push the air where we want it to go. But that is basically how this thing's going to work. So now your end pieces are cut. You're going to have one end piece that actually has the handle of the Fuigo and one piece that just has an air vent. So air vent up the top, that doesn't matter where it is, it's just put it somewhere on this end piece and you'll be fine. The pull handle though needs to be in the same place on the piston inside. So a good rule of thumb is just to put it in the center. And since this is a square, because of our critical dimensions, it's going to be perfectly square or rectangular, however you've done it. That means you can draw lines from the corner to the corner, and where they cross will be the center. That's just geometry. So one additional piece that I forgot you're going to need is a dowel. Doesn't really matter what size dowel it is, it's just that you want it to be stout. You want it to be nice and strong. This is going to be the part that's working all day, all night, if you're forging all day and all night. So something that's like nice oak or something. Almost every hardware store is going to have this. If you can't find a dowel, use a broom handle. Broom handle works great. Plus, it's nice and stout. So when you drill that center hole where the handle's going to go through, make sure it is as close to this dimension as possible. Otherwise, there'll be an air gap around it, which will allow air to escape. You want this to be nice and snug. So you're never going to get this perfectly exact, because you still need to be able to a way to demonstrate this. It still needs to be able to slide through. Trying to work out how to do this one-handed. You still want it to be able to slide very freely in and out. Getting a better seal is something we'll do a bit later. These top holes where the air is going to go in and out, it's not important how big they are. But what is important is that all of them, both on the ends and inside on the air gate box that's going to be down here and on the outside, all of them have to be the same size in order to make a really smooth moving one. It's not 100% necessary, but if you want a nice smooth motion of air, having all of them the same size establishes a consistency in the push and pull force required to operate the Fuigo. Now we need to cut out our sides for the Fuigo. This is made really easy because we've already cut these end pieces, which sort of give you a guide of, you basically scribe a line there and then cut to that line across the length of it. Make sure it is the correct length, so you'll trim off the ends and you'll have yourself two very even sides because you're using measurements you already have, which means you don't need to bring out a tape measure at all to do this. So with the sides built, you'll kind of be able to assemble it into a box. If you don't have 90-degree clamps like this, you don't need them, but they make it really, really easy to do fit-ups of things. Now you can see, because of the warps in that plywood, it's not going to be perfectly straight and everything, but we're going to screw in the sides, and then we're going to use bits of plywood. This is our measuring stick, but we're going to use bits of plywood to stick to the sides, and that's going to actually reinforce it and prevent that bow. The thing we're looking for is that we can take our critical dimension block, slide it in there, and see it's pretty much touching there and there, and can slide the whole way without much resistance. And it keeps that same level of contact more or less the entire time. That's what's going to create our good seal. Now the felt that we're going to put in later is going to help with that. But at this point in the game, if you can get it this good, you're going to get a working Fuigo. The tricky part is going to get that same action happening while the critical dimension this way is set up. So next we need to think about the shelf that's going to be sitting on the bottom. But in order for it to sit on the bottom, it needs a bottom to sit on. So let's make the bottom. So when cutting our base, we've got to think about how this is going to be mounted. So if I pick this up and stick it down on there, see how I've deliberately done it so there's overhang on the sides? That overhang will allow it to be screwed down, because like a crank blower, you've got lateral force going like this, so the thing naturally wants to move this way and this way. So you've got to mount it securely at the base to stop it from rocking. This one is going to have a big pull handle that we slide out and slide in. So it's going to want to scoot forward and backwards, which means you really want to screw it down to a table. Leaving a little bit of a flange on the bottom plate is going to allow us to do that. I like to keep it nice and flush at the front, and I'll also keep it nice and flush. I'll trim this off so there's just overhang on the sides. And once that's done, we can actually start putting measuring out the little valve that's going to be getting in the bottom of this. Now this Fuigo floor, now that we've cut it out right to size, is still quite bowed. I don't know if you can see that on here, which means it's not going to want to sit flush with the bottom, nice square bottom of our Fuigo box. But if we screw up from the bottom at intervals, it's going to sort of pull that curve out of it, since the bottom of that is a known straight line that we've cut with the circular saw. So that solves that problem. So if we go back to our original sketch, this is the little box that we're making now. Now this little box has these air gaps here and here, so it's not as long as the whole Fuigo, but it's almost as long. Now this distance, ideally you want it to be the same as this distance. So we've actually marked it out on our sides. Remember these? We've got 6 centimeters there. So basically we want it to come in 6 centimeters from the ends. Now we've got our known dimension for the inside. We just need to add 6 centimeters to either end of it, and we can actually cut the take 6 centimeters off each end of it, and then cut a piece that is the critical dimension width and 12 centimeters less than the critical dimension length, and that will be the top of this box. And then we just need 6 centimeter pieces that are critical dimension width to fit in there. One point of note here, this isn't super important on a project like this except around the critical dimensions. You have to accommodate for the thickness of the material that you're using. Now I'm not giving you those measurements in this one because you can make this out of 12mm plywood, 7mm plywood, 9mm plywood, it doesn't matter, so long as you maintain the critical dimensions where they matter. And in a project like this, there's a certain amount of wiggle room that if you haven't accommodated for the thickness of the material, you can just trim down the dimensions of the piston and everything. The main thing you're looking for is nice 90-degree angles, squareness. So when I say leave 6 centimeter gap on either side because that's the height, then I also mean when you are making the cut and measuring it all using your known measurement stick, you want to accommodate for the thickness of the plywood. I'm using 9mm for this project. Could be done with anything, so just accommodate for it. Alrighty, so this is going to be the top valve cover and also the bottom that the piston is going to run against. And you'll notice that if we line it up here, it sits in, and you've got a gap at that end and a gap at that end. So now on the underside of this, we need to put a 6mm wall here, and a 6mm wall there, and a 6mm wall in the middle. And those walls need to have holes in them that match the size of the intake air holes. Now here's where things necessitate some precision. So this is our known internal dimension, and this is the end plate where the piston arm's going to go through, and we're going to air valve there. If we put this way here, it matches our known dimension stick. We need it to match it this way as well, and this is where our air valve is going to go. So when you're cutting the vertical walls of the air valve, you need to accommodate for the thickness of the material. So when you're marking it out, don't just use your measurement stick, use the measurement stick and then an offcut of the plywood, put up flush, and that is the height that you're going to be using. Otherwise, when you assemble the box and then put your piston on using the known measurement height, the top of the piston is going to stick out the top of the box. Now you can just trim that down, that's fine, but it's easier just to do it right the first time. Okay, so this is kind of what the layout's going to be like on the underside of that bottom box. The sides don't have to worry about because that's going to cover it. But you're going to have a piece here, a piece here, a piece there. Now, when it comes to critical dimensions, the height of these three pieces is pretty critical. You want them to be as identical as possible in terms of height, because this is going to be supporting the length of the piston, and it's going to be the bottom underside of the piston's sweep. So that's going to be the sides. We're going to reinforce those with plywood to make them nice and straight. But this one we can't reinforce with plywood. It's reinforced from underneath with these. So they're all nice and even. I've made sure of it. Now I'm going to put a hole in this one and a hole in this one that matches the diameter of the hole for our air vents. So that's going to go on there. Doesn't really matter, more or less center's fine. It really doesn't matter where. You just want to have some space around it for the valve system that you're going to install. Okay, so that's going to be the centerpiece. No hole in the centerpiece, but the end pieces, they have holes. Now you'll notice that I've offset the holes slightly. It's because we're going to be putting leather flaps as one-way valves, and we really need somewhere to stick down the top of the leather flap so it can fold. I just like to leave a little bit of a gap there, just because we're working with fairly narrow walls. So the way these will be mounted, because the flaps always need to hang down, will be mounted like that, with the wide side attached to the roof. And at this point we can actually do that. We can basically, you want lots of wood glue, judicious amount of wood glue, because that creates a seal, and then we're going to affix it from the top. I'm going to use a nail gun, but you can use screws so long as the top is nice and flush. Just try and get it as flush as possible. Okay, so here it is assembled. And that's going to be our base. Now, it's got a bow in it, but because these are all the same length, once they're bolted to the base, we won't have no problems. And so solid one in the middle, valve ones at the end, with enough space for the leather flap to sit. So for our one-way vents, we basically want little rectangles of leather, and I use a Stanley knife to score both sides so they flop really easily, because leather on its own is kind of stiff, so you want this to flop. And what's going to happen is the suede side is going to go against the wood like that. We're going to staple that down to the wood, and this is sort of going to freely flap like that. So when air blows this way, it's going to close, and when it sucks in, it's going to open up. And it's a simple one-way valve. For a little bit of added support on the valve, you can staple on a little bit of wood like this. It just helps it fall closed again. Doesn't have to be much. And you don't want it to weigh too much, but it just ends up helping after a while. So it just wants to stay closed naturally. So just make sure that whatever you attach it with stays flush. Ideally, you probably wouldn't want to staple it, you just want to glue it so that it doesn't interrupt the seal here. But we're not looking for a perfect vacuum seal, we're just looking for something that closes and lets the air go somewhere else instead of this way. So that's all the valves done. We got the front plate, and when you're actually running it, you'll hear this great knocking sound. It's quite cool. But yeah, front plate, valve going in, back plate, valve going in. These will both face inside. And then the same with the air gate at the bottom. The valves both point in. No part of the outside of the flap. You won't see any of this when you're operating the machine. If you've built it right, all the flaps are on the inside. Same with these outside plates. You'll just see that. And now we're getting to the point where we're close to actually assembling the thing. So this is our base plate, remember, and we've got the overhang on either side so it can be screwed down. the base plate needs to be attached to the valve. I do have 4 fingers, by the way. I'm just holding this pen. Woo. So, yeah, these need to be affixed to this. Now, it needs to be put on there nice and square. So, you want to place it like that. Get your measuring device or something, a reference point, and make sure that this dimension is the same as this dimension is the same as this dimension is the same as this dimension, and that'll be centered. Once it is, you can mark where those pieces are going to sit and drill pilot holes, and the pilot holes will allow you to screw in from underneath, securing this down. So once we've got where the feet are going to be marked out, I've drilled my pilot holes. And then on the other side, it's a good idea to countersink your pilot holes so that the bottom, wherever you screw this down to, it'll sit flush and you won't have screw heads sticking up. But now we're going to put screws through, but only have the tips of the screws sticking out a couple of millimeters. And that way we can use it to make impressions in here and then pre-drill the pilot holes, and that way we won't get any wood splitting open. I'll show you what I mean. Okay, so our screws are sitting up just a little bit. Give that a focus. Just a little bit. But it means when we actually go and put this on top, we can line it up with our marks. And then when I press down a little bit, I now have a divot there, and a divot there, which show me where I need to drill pilot holes in order to have them sit in there. Now this one's probably going to blow through into the valve hole. It's not going to affect the function of it whatsoever. There we go. It's all now one piece. And we got wood glue in there to make sure there's minimal airflow. Now people get a bit paranoid about little leaks of air, but the fact is the physics is on your side. Air always takes the path of least resistance. So this will work very, very well. So now has come the time to process our sides. One of the sides is going to have the exit valves on it, and we'll be doing something with that later. But first we need to actually rigidize the sides. So we're going to be using our pallet wood to put basically supporting bars down each side. You're just going to glue or screw, or both, a piece like that and a piece like that onto the side. And that's going to help keep it nice and straight for our piston. Plus, you know, adds a little bit of more visual appeal, which is always good. Just remember that if you're going to opt to screw from the inside, remember this is going to be the surface that our piston is running across. So it needs to be really, really flush and smooth wherever you put screws. Don't have anything sticking up that could catch the piston as it passes by it. There you go. So you can see how much straighter that is now, just because of that lamination with the pallet wood. Even if the pallet wood is not perfectly straight, laminating pieces of wood together like that end up helping keep it straight if you keep it clamped straight while you're attaching them. So this side is going to go there, more or less, and screw into the side, but we'll get to that later. One thing I want to point out is once you've done one side, you'll be doing the side that the vent is going to go on, the exit vent, which is going to have 2 holes coming through the bottom of the side that's going to be here. So it's going whoosh, whoosh. So when you are doing your screwing of the wood together like this, make sure there's no screws in the middle bit here, because you're going to be drilling holes. In order to make up for the strength, before you screw down the bottom piece, either side, give it a layer of wood glue, which you probably should do anyway, but because it gives it extra strength. But yeah, just keep in mind, you don't want screws in the area that you're going to be drilling holes through. So you can see here, this other side that I've done, there's no screws in the section where it meets the valve. So, pretty straightforward. Just pretty, use common sense. Just miss out the middle screw. You'll be fine. That way you can drill 2 holes, the same size as the vents you've been doing, and it'll work out swell. So now that we've got 2 matching sides, we really want those to be smooth as eggs. Now, I would go a minimum of 120 grit sandpaper and just do it by hand. It won't take long. Plywood's already pretty flat if you're using plywood, so it doesn't need to be perfectly flat. The felt that we're going to use in the later part of the video is going to eliminate the need for it to be perfectly flat, but we want it to be largely flat. The more flat you make it, the better seal you'll get, the more airflow you'll get. It's pretty simple. Okay, so this is the side that doesn't have the screws, because this is where the valves are going to be going. And we have our air gate here, and this is the central wall. So in this side, we want to have a hole for this side of the air gate and a hole for this side of the air gate. So to know where to put those holes in that side, we can mark off the height of the shelf there and roughly where the center is. And then when we put it there, we know we need to put a hole about here and a hole about there. Doesn't really matter, it doesn't have to be perfect, but yeah, that means that you won't end up having the hole accidentally overlap this side piece. You also don't want it to be too high up the wall, because then it'll be above the level of this, and we want it to be below the level of this. So another good tip would be to accommodate the bottom thickness if you've got it overhanging, but since we've actually got this as the floor, it's never going to be overhanging. So yeah, now we can drill those holes for the air vent. Alrighty, so got our 2 holes drilled in the right position. Comes out the other side like that. And when I line this up on the side like that, if I look inside the vent box, one side has a hole, the other side has a hole. So now we need to cinch it down to the bottom so that it sits flat, and cinch it to the sides of the air vent so it sits flat. Now the best way to do this is to actually get your pencil and scribe all the way around the outside, and it gives you a guide of where to put pilot holes so that it all lines up. Same on the bottom. Pilot holes, pilot hole, pilot holes. Put your screws part way through, just like we did before with this, and that way you can get it to all line up properly. And once it lines up properly, because the screws act kind of like guide pins, we can put a big old seal of glue and then put it in there and screw it all together, and that side will be done. So just in case that last instruction made no sense, see here I've sketched this out, and it lines up perfectly with the sides of the air vent, including that central line there, which you can see lines up. So when I put my pilot holes in, they'll line up with everything and I'll get a good seal. So if you are seeing a little bit of glue squeeze out along here, that's a good sign. You want to clean up most of it, but it means that you'll get a really nice seal all the way around. Like I said, it doesn't have to be perfect, but it means that it's flush. So now that you've got the sides on, if you've done it right, these ends should kind of pressure fit in there. You can kind of get an idea of the size and general shape. And remember, your valves will be pointing in, like that. So you get to decide which is going to be the front and which is going to be the back. But basically at this point, you want to have these here, drill pilot holes, fix this in, and then run a bead of glue around that so that there's a bit of a seal. And that's the next step. So let's get these fixed in, and then we can work on the piston. So I've secured this side in, and you can see I've been quite judicious with the glue. At this point, there's really no such thing as too much glue. You really want to create a good seal there, and you want particularly this side, which is the front, which is actually going to have the piston plunger in it. You want that to be in there as solid as possible. So I've actually run nails down there and along the bottom, and I've also got screws in the corners. And that one is in solid as a rock. And with that, once that glue sets, it'll be even stronger. So I'll do the back now, then we can work on the piston. So that makes the box built. Access to the valves is down in there. Now we go to the piston. So we're going to take a piece that uses our known width, slot it in. I'm going to sneeze. Bless me. Alright, so this piece is our known width, so it should fit all the way back and forth without catching. And if it catches, you just want to sand down one of the sides a little bit. Now, you actually want this to be a little bit narrower. You want there to be a gap, because we're going to wrap this thing in felt. And the felt is going to act as like a gasket. So, actually aim to make this a tiny bit loose. You really want like a millimeter gap. So, make sure that it slides all the way. Now, it doesn't need to slide all the way to here. It just needs to slide to the end of this shelf. We're going to put little stop blocks there to ensure that it can't slide any further, but just give it a few test passes, make sure that it works okay, and then once you're happy with it, put it against the side of the Fuigo and sort of mark along, so you know where you need to trim that down to make a square. And if you've done that right, it should be more or less your known measurement. Mine's a little bit taller, but that's because I didn't account for the thickness of the material, so that's what's left. But this is why you can actually use reference points on the project itself to ensure that that line matches up there and there, and trim it off. Alright, so the piston piece is probably going to have the most refining of any piece. You want it to be a square, mostly, but you want it to fit well that way. I'm going to sneeze again. Sawdust. Anyway, you're going to make sure it fits there, slides the whole way that way. And in terms of height, you want to make sure there's going to be slight variances unless you've cut perfectly laser straight, which is probably not really possible in a home shop. But there's going to be differences of like 0.5 millimeter, but those differences are going to bring these edges above the height of this, which you don't want. You want it to be just below the height, because you know that little gap that we're talking about here? You want that same gap to be on the top and bottom. So make notes on the piece. So if we have our piston, that is up, and we're going to go from looking from the front. We're going to say that is left and that is right. That way we can know we need to shave down this a little bit, because up here it's a little bit higher. Here it's pretty good. So let's check it at this end here. So it's pretty much flush here, so we're going to take it down a little bit there, and it's a little bit higher there again. So clearly the top of this board isn't exactly 90 degrees. So if we take that side down a little bit and this side just a hair, we'll refit it and see how it goes. Okay, so this is pretty good now. It slides back and forward. We got a nice gap on the top and the bottom. And so what we want to make sure we do is slightly round over the edges and get those corners just a little bit rounded off. Sand this puppy smooth, and it'll be ready for us to attach the piston pivot point. This part's pretty self-explanatory. You just want to make a couple of blocks with a hole through it, and they're going to be attached to the back of the piston, right in the middle, more or less. There's not real precision needed here. And this is going to sit between them. You want to have enough room between them to be able to fit this loosely, not tight, but not too loose, not too tight. The only dimension here that matters is that you want to get them central to this axis. So basically this ends up sitting right in the middle. And once you've got it there, you literally just put some wire through there, or screws, or a nail, and you bend over the end of the nail or something to hold it in place. Obviously, if you want this to last for ages, make this more reinforced, because this is the part that's going to have the most wear on it. A lot of people like to actually make this fixture metal, but you can do it quite sturdily with timber in a way that lasts a long time. But screw it in from the other side, obviously make the screws nice and flush, and then we'll move on to felting the piston. So here's a little mock-up of how the piston sits in such a way that you can see the final step you need to do in shaping the piston. Because we have a rod that's pinned in here like that, and it goes all the way out the front, and that's what the handle's going to be attached to. but we need to limit the amount this can actually rotate. And the reason for that is if we pull on it without any limitation, it'll just fall over and it'll sort of flop around in there. We don't want that. So basically, we want to give it just a little bit of wiggle room, because this is why we're not screwing this piston directly into this. It's going to lead to problems. You need to actually allow it to have a little bit of room in order to create a smooth flow. So we need to put a piece across here and a piece across here, glue it, screw it, and reinforce it so that we actually get just a little bit of play, but not enough so that the piston's going to fall over. And so you can see we put that there, glued and screwed for ultimate strength. But now when we slide it in and out, no falling over. Alright, so let's felt that piston. When I say you want to felt the piston, I really mean cover it in felt. Fake felt's fine. But sort of go nuts with the staple gun on the back. Hold it down. You can get fabric glue as well, which will adhere fabric to wood very well. But just make sure where you fold it over, you sort of tuck it in so it keeps it away from the corners. You don't want this coming loose and binding up. Really go ham with that staple gun and get it on there nice and tight. And that will help create that really nice tight seal. And the felt is soft enough that it'll allow it to move, but still sort of save it from any little gaps from having air squeeze out. Now, before we sort of assemble all this together, you really want to get in and grease the sides of it. Any type of grease is fine, but just really get in there with grease and make those sides completely coated in it. It will help you out quite a bit. Actually, no, scratch that. Before we grease the sides, we're going to put the stop blocks in. So basically, just little pieces. You want to put one at the end there, glued and screwed. Another one at the end here, glued and screwed. Now this is going to be mirrored on the lid, and this is going to stop the piston from flying off over the edge, because you don't want it to go back too far. So glue and screw, and then we'll move on. Grease me up, woman. Alright, so double gloved, because you don't want slippery hands for the rest of this while using power tools. And grease all these sides here, all of this here, all here. And while you're there, a little bit of grease in there as well. And grease the shaft as well that you're going to use. Now that is something you should not say on YouTube, kids. But we're going to do it anyway. While you're getting grease lightning on the inside of this thing, make sure it's nice and smoothly greased. You don't want big lumps of it, because that will just get in the way of the piston. So just nice and flat, run your finger along it. Brush it down flat, get rid of any gobs. And that'll ensure a good greasy seal. Okay, so that's a nice thick coat of grease. Now, the reason we put it on so thick is because we don't want to miss any spots. We want to fill any voids, etc. that may have gone into the wood. But now it's time to wipe it off. That felt is going to drag across there, and it's basically going to goop up any excess. So if we wipe off the excess with this, like, you'll never get rid of the grease with just this, but you will get rid of the excess. So go over it with the rag, and you'll start seeing the wood just peek through a little bit, but a lot of the excess will come off on the rag. When I do that over the whole thing and get rid of that excess. So with our handle installed, you can actually kind of see why the play in the piston is super important. Watch how much it moves as it goes. But that will create a very nice tight seal around the outside of our Fuigo. So now, by the way, all I did here was cross the dowels, sanded off a flat spot, buttered that up, put some nice strong wood glue in there and a thread down the middle. It's not the best handle in the world, but this is just an indicative Fuigo for a YouTube video. Make something nice and comfortable and nice and strong, because you're going to be pulling and pushing that all day long. Now, before we go sticking a lid on top of this thing, we need to make a gasket. Now, you could actually do this with rubber gasket sealer, you know, you can get for cars and oil pans and things like that. But since we're using felt for our gaskets in this one, keeping it nice and traditional, one thing you can actually do is run a folded over, like a wrapped up piece of felt all the way around and fix it down. And when you put the lid on, you will still screw it down. But like any tool, a Fuigo requires maintenance. You need to re-grease it sometimes, or maybe the pin will break and you need to replace it, or the piston, or just whatever breaks down. You want to be able to open it, fix it, and then put it back together again. So creating a gasket that is reusable is super important because it keeps the air in, keeps that seal, but allows you to take it on and off, because we've been using wood glue for most of the seal. But this one is designed to be opened. So rolling up some felt and putting it all the way around the outside edge before we screw the roof down will allow that to happen. There we go, all the way around, nice and securely attached. You wouldn't think that felt would make a good seal, but when you screw down the lid and actually have the downward force of the lid there, you'd be surprised at how much of a seal that you get. Making the lid's pretty straightforward. I don't need to show you guys how to make a rectangle. But I've put a couple of pieces of the pallet wood across the top to help keep it nice and straight. Not super necessary at this point because this is going to be maintainable. I've countersunk these screw holes here, which actually line up with the sides of the Fuigo, so the lid can be taken on and off for maintenance. Those screws are actually going to hold it flat anyway, but you know, it kind of looks nice. It came out nicer looking than I thought it would with those bits on the side there and everything. So it really ties it together, sticking that there. But I don't know. But basically, you've got a rectangle here, and I've marked on the inside where the edges of the Fuigo are. Now we've got to grease this so that it acts correctly. So once it's done, you can give it a test. Now, we have 2 exit ports at the moment, and we're going to condense them into one by building a little box that's basically got just a box with a hole in it, so there's one output port. But before we do that, I just wanted to show you against this grass just how much air force this thing can generate. It'll certainly give you a workout compared to a crank blower, but these things get the job done just fine. So like you saw, we have 2 exit ports. When we're pushing the air in this way, air blows out this one, and when we're pulling the air back this way, air blows out this one. But we just want one port because that's going to go to our forge. So we're going to build basically a small box that connects around here, that has a top, a bottom, 2 sides, and a faceplate. And the faceplate is going to have one hole where we will attach our, basically the blower port that will connect to the tuya of our forge. So I'll get that knocked together, and then we'll glue and screw it so it's a nice tight seal. And there you have it. One Fuigo, sometimes called a box bellows. Rear valve there. Got the box for connection to the tuya. We got the front valve pull handle, removable lid, and that there is a very functional and workable, very traditional forge blower, one that you can make at home. So get on it. Hope you enjoyed this. So there you have it, a box blower, or Fuigo, which is the Japanese word for it. And they've been used for hundreds and hundreds of years and are still used in a lot of traditional Japanese blacksmithing. I highly recommend checking out both Floris Postmus, whose channel I'll link above. He has a great one. And also Island Metal Blacksmith, I think he is called. He uses one and does a lot of traditional Japanese forging. They are a really good way to get into blacksmithing, especially since forge blowers that are crank operated and geared can be either rare or very expensive. And this you can build yourself from literally scrap. If you didn't want to use plywood, you could always bond together multiple plywood boards, pallet wood boards I should say, and create the sides that way. Make the whole thing heavier, but heavier is good with these things because you don't want it to move around. So hopefully this has made you think maybe I can build a forge and get going if you've been struggling to find a blower solution. So if you like that, hit that subscribe button And be sure to follow me on Facebook and Instagram, and also check out my Patreon, because my Patreon, listed in the description below, is filled with great little project ideas and tips and business advice from my past life as a business advisor. And I hope to see you there. But otherwise, I'll see you on the next video. Catch you later.
Can you see him blowing in from the sea? Oh, so lying fables. It's not like I'm the one.